Hello, guys. Hello, guys. All right. We're going to be getting in here and getting started here really quick. Just giving a chance for everybody to get in here. Hope that works out. Seriously, Pathman's here. All right, we're going to be starting here in just a second. Hope this all works out good. Get everybody ready for this test. In the chat, can you show up if anything is showing up on the screen? It should be showing what I got going on here. All right, can you see it now? All right, can you see it now? Hey, there we go. Now it's working. All right, can you see it now? Hey, there we go. Now it's working. All right, so we're going to get started here going over translations. All right, so I'm going to try to monitor the chat as I'm going. I'm going to give it about 2 more minutes because I told everybody it'd be 7:30. Everybody, it'd be 7:30. Everybody, it'd be 7:30. Are you guys hearing some weird feedback in there? Are you guys hearing some weird feedback in there? How about now? Okay. All right, here we go. We're going to go ahead and get started. We're about a minute early. So what we're doing today is we'll be working on chapter 9. This is going to be our summative for tomorrow. So we're going to walk through this and hopefully get everybody ready for the test. All right, here we go. All right, so we're looking at the first one here. We've got pairs of figures. We're trying to figure out how they are related. So, first things first, we got the first one here. These look like you just picked it up and moved it. That's going to be a translation. That's what a translation is. It moves it up, down, left, or right. The second one, this is a reflection. As if you put a mirror right there, they'd be exact mirror opposites. That is a reflection. Then we have this guy that looks to me like a rotation. All right. This last one, again, looks like a reflection to me. That is reflection. All right. Now we're going to get started with question 2. Question 2, we have a figure here. It's been marked with a large dot right there. First, we're going to translate the figure 5 units to the left and 4 units up. Then we're going to give the coordinates of the marked point in the original figure and in the final figure. Well, in the original figure, this point right here is 4 for the x coordinate and -8 for the y coordinates. We have 5, -8. Then if I move it 5 units left, 1, 2, 3, 4, 5. Oh, we said that was 4, -8. Sorry about that. Okay, so 4, we're going to go 5 to the right, 5 to the left. 1, 2, 3, 4, 5. We're moving 4 up. 1, 2, 3, 4. That's the new point. The new point is -1 for x. -1 for x and -4 for y. Yeah, 7th grade accelerated is what we're doing here. So really, this is 8th grade math. Here we go. We're going to go on to the final point. There we had it. We're going to go on to number 3. Question 3. Now we have this quadrilateral, which is just a 4-sided shape. We're translating it 1 unit to the left and 4 units up. 1 unit to the left and 4 units up. That means every point on the whole shape. So let's go ahead and get this going. Hang on just a second. All right, here we go. Having a connection issue. Give me a second here. All right, here we go. All right, so everything goes. We're going 1 unit to the left and 4 units up. So this one's going to go 1 unit left, 1, 2, 3, 4. New point. This point's going to go 1 left and then 1, 2, 3, 4. This point will go 1 left and then 1, 2, 3, 4. And this point, 1 to the left and then 1, 2, 3, 4. Now we're just going to connect those points. And we have our quadrilateral shifted 1 unit to the left and 4 units up. All right. Any questions on that? Okay, here we go. Moving on to number 4. All right, so we have the point A shown below. They want us to reflect the A across the x-axis. So the x-axis, of course, is the horizontal line here. We're going to be reflecting it across that line. So we have to see how far away it is. This is 3 steps away. 1, 2, 3. So we're going to go the exact same number of steps across the line. 1, 2, 3. Right there. Then they want us to go across the y-axis. So this is 1, 2, 3, 4, 5, 6, 7 away. So we're going to go 1, 2, 3, 4, 5, 6, 7. Now they only want the final dot in the answer, so we're going to erase that one, and we're good to go. All right, here we go. Let's move on to number 5. Number 5. We have point A. They want us to reflect it across the y-axis. Y-axis is vertical. We're 4 steps away, so we're going to come 1, 2, 3, 4. And there's our final point. All right, that was pretty easy. All right, now we go to question 6. Again, this time we're going across 2 axes. So we're going across the x-axis first, but it's on the x-axis. So it means it doesn't move at all. It just stays right where it is. Then we're going to move across the y-axis. And again, this is 5 steps away. So we're going to go to the 5 steps away on the other side. And that is our final answer. Again, that's a little trick they like to play on you. So make sure you get that right. Moving on to number 7. Figure below is marked with a large dot right there. We're going to reflect the figure across the y-axis. Then we're going to give the coordinates of the marked point in the original figure and the final figure. Yes, I'm doing all the questions. All right. So the original figure, this point is -7, -2. That's what we're starting with. So we're reflecting it across the y-axis. So it's going to go the same distance across the y-axis here. So it is 7 away. So we're going to go to the 7. That's the new figure there. So the new point is 7, -2. That's it. All right. Let's go to question 8. Now this one, they take a graph away from us, and they want us just to know what we did. So we have the point 7 and -6. We're going across the x-axis. So when you reflect across the x-axis, that means we change the y. So the y currently is -6. So it's going to go changing signs. It's going to be now +6. When we go across the y-axis, whoa, what happened there? When we go across the y-axis, we change the x. So since we have 7 and -6, we change the x. Now that's going to be -7 and -6. All right, and that's the key. So if you're going across the x-axis, you change the y sign. If you go across the y-axis, you change the x's sign. All right, we're halfway through, guys. Let's keep going. Number 9, we're reflecting the point 9, -5 across the y-axis first, then across the x-axis. So here's what we're going to do. We're going to write the original point right here. Now we're crossing the y-axis. So when we cross the y-axis, that means we're changing the x. So that means we're going to have -9 and -5. And then that point gets reflected across the x-axis. When you cross the x-axis, we change the y's sign. So now we have -9 and +5. And this is going to be our final answer here. That okay? All right. On to question 10. Now we're into rotations. So we're going to draw this triangle after a 90 degrees clockwise rotation about the origin. So here's what we're going to do. We got 3 points. We're going to write them all down just so we can see what we're doing to them. So first we have this point here, which is -2, -1. Oh, -2, -1. This point here is -5 and -3. And this last point is -4 and -5. All right. So we got the 3 points. And what we need to do now is figure out how we rotate. So any 90-degree rotation means you're going to change x and y's position. So it goes from being xy. Wow, Jeff is really acting up today. All right, xy is going to become yx. Okay, always, any 90 degree. Now, when it is clockwise, meaning it turns this way, the new x becomes, or the original x becomes negative. Now, if we go counterclockwise, just really being acting up. So counterclockwise means you're going to turn that way. That means that the new y, or the old y, is going to change. Okay. But since we are in a place where we're doing the clockwise rotation, we're only doing clockwise here. That means this x will become negative. So each of these points has to change now. So we got -2, -1. This point, if we change it, it's going to become -1. And then we're going to change the sign to make it +2. That's how that's going to work. Our next point, we have -5, -3. That one, we're going to, again, switch signs on the x, which is now the y, and become positive. Then, our last point, we have -4 and -5. Wow. -4, -5. That's going to become -5 and +4. So we'll go ahead and plot these points and make our triangle. So -1, +2. Oh, -1. Oops. Let's go ahead and remove these points now. Here we go. -1, +2. -3, +5. And -5, +4. So this is our triangle rotated 90 degrees clockwise around the origin. How's that? All right. I know these rotations can be a little tricky because there's a little bit of work to them, but it's going to be okay. Let's go ahead and go to number 11. Number 11, we have drawing the following segment, 90 degrees rotation, counterclockwise about the origin. So again, we got 2 points. It doesn't show any points here, but you can see that these are 2 points. We're going to go ahead and just write them down. This is going to be -1 and +5 for the top one. And then we're going to have 3 and 2. 3 and 2. Now, since this is 90 degrees counterclockwise, we're going the other direction rotation. That means the XY is going to change into YX. But this time the Y, the new X or the old Y, however you want to look at it, that one changes signs. But always with a 90 degree, they always change sides where they're at. So -1, 5 becomes -5, -1. 3, 2 becomes -2 and +3. Let's go ahead and draw our new points. So we have -5 and -1. We have -2 and +3. And that, my friends, is our new line. There it is. Excellent. All right. Let's go ahead and move on to number 12. We're almost there, guys. We're getting through it. So we've got a 180 degree rotation now. So we didn't talk about those before. So we have a 180 degree rotation. That means that your XY coordinates are actually going to stay in the same place, but they're going to become the opposite sign here now. So -X, -Y. So since our original points, we got 3 of them. Let's go ahead and write them down. We have -5 and -1. We have -1, -2. And we have -3, -4. So again, when we change these, rotating them 180 degrees, that means that they stay in the same place, but they're basically going to get the opposite sign. So since these are all negatives, they're all going to become positive. It'll be 5, 1. This is 1, 2. And this is 3, 4. Those are the new points. Let's go ahead and graph them. So I have 5, 1, 1, 2, and 3, 4. And we'll draw our lines. And there it is. And you can tell it looks like it rotated right around there to the new quadrant. All right. How does that feel? Hopefully you're feeling pretty confident now. All right. Moving on to number 13. You feel like a 5? I like it. I like it. Remember my 1 to 5 code. All right, here we go. Now we got dilations. So dilation of this figure, starting with figure A, a dilation was applied, and then the result is figure B. So what we're trying to do is find the scale factor. How much bigger or smaller did the new figure get? The key I always told everybody here was that the new always goes over the old. So the new shape side always goes over the old one, and then we reduce the fraction as much as possible. So we could take any one of three sides here. We can take the top, we can take the left side, we can take the bottom. I'll let whoever's in the chat decide how we're going to do that, top, left, or bottom. You can't take the diagonal because it doesn't really give us a true straight, a length there. I'll give it a minute for chat to decide. All right, I see bottom. Here we go. So if we're using the bottom, figure A has 1, 2, 3 on the bottom. So figure A is the old one, so that's going to be 3. Figure B has 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the new one. It goes on top. 9 divided by 3 gives me 3. And since it's a number greater than 1, that means it got bigger. And that should be what we see in the figures. A got bigger to become B. And in fact, it is 3 times bigger. All right. So that's another way they can ask questions of you is how many times bigger is B than A? That's another way they can ask questions. So just so you know. All right. Good stuff. All right. Now we got 14. This is going to be similar triangles. So we got 2 triangles that are similar here. We have triangle ABC and triangle XYZ. We're missing a side right here, and we need to find it. Okay, I don't know why the shape looked like that. That's weird. Trying to make a circle here. There we go. Okay, so we're missing that side. We have to relate one side of one triangle to another side of another triangle because that way we can make a better determination of how much bigger it is. Here we go. The way we do this is a proportion. We're setting 2 fractions equal to each other. So we're going to take the sides of triangle ABC, put them over here. Sides of XYZ, put them here. The way we do this, we take one of the sides of the triangle. In this case, we'll take the one that has the question mark. I'm just going to put it on the bottom just because it makes sense to put it on the bottom. You can put it anywhere you want. And then that corresponding side on XYZ, since that's AB, XY is on the same side of the triangle. That means a 2's got to go across from it. Now I could pick any other 2 sets of sides here. We already chose those 2. I could take the 16 and 4. I could take the 12 and 3. It doesn't really matter. I'm just going to take the 12 and 3 for this one. So we got 12 on the ABC triangle. And I have 3 on the XZ triangle. They're corresponding sides. And then what we're going to do is we're going to do what I call the MD method. The MD method, oops, a student came up with this years ago for me. They called it this. MD stands for multiply, then divide. We're multiplying always the diagonal first. Then we divide by the only other number we see, and that gives us the final number. So 12 times 2 is 24, and 24 divided by 3 is 8. That means this side that's missing, the length is 8. And there it is. All right. Well, we got a couple questions left. I hope this is being helpful to you guys. And hopefully all those that weren't able to join us tonight can jump in and watch it at some point before tomorrow. It's all good, Tyler. Glad you're here. All right, here we go. Number 15. I'm going to move this stuff out of the way here. All right, we got these 2 similar triangles. We've got triangle ABC, we got triangle PQR, and we're trying to figure out, how they relate to each other. There's 3 proportions below. The ratios in each proportion compare the length of one of the sides of triangle ABC to the length of the corresponding side of PQR. Here we go. We have AB, which is 3 here, right? They want to know which triangle length on PQR matches up with that. Well, this is on the left side of the triangle. That's the left side of that triangle. That's got to be 12. And that's PQ. So this is the one we would select. It is P and Q. All right. And 3/12 can be reduced. What's the reduction of 3/12 if we reduce that? You can go ahead and type it in the chat there. I'm waiting to see if anybody types it in the chat. If not, I'll just do it. Okay, so 3/12 reduces to 1/4. Okay. All right, for the second one, we have AC, which is 4. Okay, that was 4. And then the corresponding side is PR, so we got to find the PR. And that's 16. And we have 4/16, which they already reduced it to 1/4, but it is definitely 1/4. Okay. All right. Then you got BC, which is 6. And they gave it to us this time, QR, which is 24. Okay. Let me get that erased here. Okay. And then that reduces also to 1/4. Okay. So we've got our 3 fractions, and look, they're all the same. 1/4, 1/4, 1/4. Okay. Now we have to choose the correct statement. It's going to be this one. Each pair of side lengths, I'm going to highlight the important stuff here. Each pair of side lengths compared is in the same ratio, meaning it's 1/4, 1/4, and 1/4. All right. This is because the side lengths in each pair are corresponding sides, meaning this side corresponds to this side, and so on and so forth. AC is the same as PR. And BC is the same as QR. Wow, that's terrible. Okay, does that make sense? And these triangles are similar. That is important. That's the reason all of that works. All right, we got one question left, guys. One left. Here it is. All right, we've got similar triangles. We're trying to find a missing length. This is the tricky one. It's probably like you're going to see this on the test since I was so picky about this and talking about it, right? Might want to pay attention. Here we go. All right, we got smaller triangle and a larger triangle. The smaller triangle is right here. The larger triangle takes this whole outside. Okay, so we're trying to make a proportion here so we can find the missing pieces. Well, let's take the smaller triangle. We got that X we got to find. This side right here correlates to this side. So we're going to put 4 over here. Now, the other side of this X triangle that we know is 5.5. And then the other triangle, the bigger triangle, here's the thing. It's this whole side right here. So it includes the 5.5 for the smaller triangle and this one. These are plus. So 5 plus 5.5 plus 5.5 actually gives me 11. So that side is really 11. Don't get confused. Good job. Don't get confused because I've seen a lot of people when we do this, they'll go, oh, 5.5, and this one's also 5.5. Not quite. So we're going to go ahead and do our calculation again. 5.5 times 4. We'll divide by 11. And since it's a decimal, it's not quite as easy to do on our own. So we're going to pull out our handy-dandy calculator here. We're going to go 5.5 multiplied by 4, then dividing by 11. And you guessed it, it is going to be 2. That side is 2. All right. That is it, my friends. I think we're ready for this test. I'm excited. I hope that we're going to see some A's. Is there anything else that you want me to cover, or do you think we covered it all? Yeah, the review is open. Go back and do number 2? Okay, I could do that. I already have all the notes in there, but I can go back and do it again. That's not a problem. All right, so number 2, we're moving the shape. So number 2, we're moving the shape. We're going to click and move it. You're going 5 units to the left and 4 units up. So you just take that one dot. We're going to go to the left 5. 1, 2, 3, 4, and 5. That's to -1. Then we're going to go up 4. 1, 2, 3, and 4 to that new point. And then we're just writing down the new point. All right. Does that help? Excellent. All right. Well, unless anybody's got any other questions, I'm going to go ahead and hop off. And I hope that you guys get a good night of sleep, get ready for this test tomorrow, and we'll keep the mathing. Ah, gotcha. Okay, perfect. All right, guys, have a good night, and we'll see you tomorrow. Oh, and go Gators. Make sure you watch that game, 8:50. But don't stay up too late. Get some good sleep.